Hi everyone, me again, Professor Francisco Simões from Informatics Center of Federal University of Pernambuco. It's my pleasure to have our second keynote of the day of the Pernambuco School on Visualization and Sustainability. Now we have Dr. Jean Daniel Fekete. It's our great pleasure to receive him online, as you can see in a few moments. Jean Daniel is a senior research scientist at INRIA and scientific leader at the INRIA project team AVIS, which he founded in 2007 and integrated into University Paris-Saclay, in 2020. With a PhD in computer science from Université Paris-Sud, Université Paris-Saclay nowadays, Fekete's research focuses on visual analytics, information visualization, and human-computer interaction. He has a great resume with more than 180 articles in prestigious conferences and journals, and received the IEEE VGTC Visualization Career Award in 2020. So, Jean Daniel has a great career in the area, so introduce him is a pleasure and an honor for us. So please, Professor Jean Daniel, make yourself comfortable and give your talk. Thanks.
Thanks a lot. Thanks. Hi, everyone. I'm not sure I'm hearing you on my side, but I hope you're hearing me well. It's a pleasure to be here. I would have preferred to be here in person. I had everything planned. All my trips were planned, but then 2 hurricanes came along the way and broke all my plans. So I'm really sorry I cannot attend physically to this meeting, but still I'll be super happy to have this presentation remotely, and I'll be happy to have discussion and questions. So this presentation is really meant to steer some discussions because this is an ongoing project that I'm going to present, and I think we need to discuss more with the collaboration of design, research, especially in visualization, and also climate change and IPCC data. So this is what I'm going to do. Again, this work, as always, when a senior professor or advisor is talking, he mentions mostly the work of his students. In that case, I've been working with Lu Ying, who's at the University of Hangzhou in China, but the Young University. But she spent 8 months with me at INRIA next to Paris, and she did a great work working with IPCC. So IPCC is actually next door. They've moved last year with at Paris-Saclay. And we started to discuss. It's not a formal collaboration yet, but we have a lot of discussion. And I want to mention what we've been doing and where we are going. I think it's an interesting and ongoing project. So, of course, well, you certainly started the discussion earlier, but the climate change is really hitting the planet hard, and it's hurting everyone and everywhere. We've heard this year of catastrophic floods in Porto Alegre, but here in Paris-Saclay, the valley next to the university is also flooded, as well as several cities. On the other side, there's been drought, and you had some, and you still have some, and we had some even now in France. And the Sahara has been flooded this year with storms, and there is a small pictures on the top. So, I mean, I'm sure I will not have to explain to you that climate change is real. But really, one of the issues that we need to address, and I need to address in terms of, because I'm a researcher, but I am also a citizen, and I think it's very important for us researchers and citizens to help in addressing those important problems, that there are still many people who are kind of skeptical or not completely convinced that climate change is there and that they need to do something in order to fight climate change. So just to be clear, I'm not going to say bad things about people who are skeptical. I think being skeptical is really important. I'm against people who are deniers because I think it's kind of too late and it's not fair to be in denial. But being skeptical is okay, especially there are many information that are difficult to understand about climate change, and there are a lot of bad information also about climate change. And so since people are naturally inclined into being skeptical, I think it's very important to convince them in a fair uh, way, but also a trustworthy way. So I'll talk about it today, and I think we had some problem. We had some problem in the past. So yes, people have dreams, and now many people are telling them with climate change, your dreams are not going to happen, and this is making them really either uneasy or sad, or they don't want to hear it. So I think our goal as computer scientists or as researcher, but also as citizens, designers, or whoever we are, is to help them understand, click, realize that there is some need of changing behaviors in order to avoid more catastrophes and to even prepare for the ones to come. And it's not about propaganda. It's not about pushing a lot of bad information. It's really about convincing, explaining clearly what's the situation. And the question I'm asking today is why would they trust us? And how can we make our communication easy to understand and trustworthy at the same place? So there is kind of interesting dilemma that I want to raise here. And this dilemma is the following. So if you want to trust people, you need to trust the climate scientists, the scientists in general. My feeling is people trust the scientists, and if they don't, I mean, it's a bit strange, but if they say scientists are only right when they heal my problem because I'm sick, but they are wrong when they talk about climate, I think it's weird. So my interpretation is that most people out there, they have no strong convictions, but they trust the scientists. So if the scientists come and tell them, here is what's going to happen, and actually they can check and this really happens, people will trust them. And so the trust on scientists is actually associated not only with the function of the scientist, because one scientist can be wrong, but about institutions like IPCC or NASA or others, where there are many scientists and they have consensus about what they are talking about, and they write reports. I think even if you're skeptics and don't believe easily people, those bodies of scientists, it's very hard to say, no, they are all lying. Why would they do that? And why would they lie to you for climate and not lie to you when you're sick and you need a cancer therapy? So people in good faith believe them. But then if they want to understand what's going on, they look at the reports, and then they do not understand the reports. The reports are written by scientists for scientists, and the reports have figures like the one on the top of this slide. And those figures don't make sense to normal people. Even me, I'm struggling to make sense of those figures because they use a lot of acronyms that I'm not familiar with, a lot of names of chemical compounds that I don't know about. And they use weird visual representation that I'm not familiar with. I can learn them, but I don't understand them spontaneously. So I'm a specialist of data visualizations. And myself, when I see these figures, I need to look up in the text to understand what this all means. But yet, I think people trust the scientists overall. So on the other direction, there are many designers, and probably part of this seminar today, this workshop, many designers who want to help. They want to help people understand climate change. They want to help people make decisions. They want to help people explain. So they create nice figures. I have here the climate stripes that is very well known. Actually, this visualization, this climate stripe that shows how the weather has been going from normal to very hot in the recent days. This figure has not been done by a designer, but has been done by a climate scientist. So it has both the credibility of the scientists and it's a good design. Turns out this scientist was a good designer, but not all of them are, far from. And on the other direction, when the designers decide to create a nice visualization, maybe the visualization is nice, maybe it's awesome, maybe it's super easy to understand, but how trustworthy is it? So if you're skeptical, you look at the visualization and you ask yourself, who is this guy making this visualization? Why should I trust this person? Because this person is not a climate scientist, so he can say whatever, he can show me whatever numbers, he's making them up. And why is this guy more trustworthy than myself or my other neighbors who said that climate change is not real or is exaggerated? And so my feeling is that now we are in this situation where people who can do nice visualizations in order to make this climate change more understandable do not have the right um, scientific background, and people do not trust them on scientific on climate change. And the people who know about climate change and scientists, they make very bad um, charts, figures, visualization, and people do not understand them. And what I would like to do is to help improve the situation and allow designers to create very good figures in order to explain to a wide variety of people, from school students to older people, what's going on and what to do about it in order to prevent it. And so the way I put it is I think we need to build a chain of trust between the data and the visualization, even if it goes through designers. So this is the way I see the problem. The problem is, to me, that there are trustworthy scientific bodies working on climate change, and they make a lot of prediction, and all of these predictions have happened. So it's very hard to dismiss if you were in good faith. But these people make very bad presentation, and so normal citizens cannot make sense of this communication. So they need to go through designers in order to create better designs and in order to understand what's going on and how to prevent it. And along the way, in the middle, there are many people who are deniers, or they want to interfere with this communication because they have some agenda that is against people understanding and acting against climate change. So I will not list them. You probably know well who these people are. But right now we are in this situation. Trustworthy people are impossible to understand. Good designers don't have the credibility when they create design by themselves. And so we need to build this chain of trust in order to allow designers to build very nice visual representation to help, but to keep the credibility. So one way to do it would be collaborate. So all the designers could say, I'm going to NASA, I'm going to IPCC, and I will work with the climate scientists. But actually, it's not scalable. I mean, how many designers can really go there and work with them? Maybe 10, maybe 20, maybe 100 at the most, but not everyone interested and not everyone skilled. So this is possible. Maybe IPCC will have a few designers with them, but clearly very few compared to the whole population interested into collaborating and making nice presentation to raise the awareness of different populations. And so what I want to talk about today is what we've been doing in order to help maintain a transparent process to improve the visualization created by IPCC or other bodies, but maintaining this trust in the process. So you see, this is an example of images I've seen. All the countries and the amount of CO2 they produce over time, created by a designer on the right. It's very nice, beautiful, but there is no mention of what these numbers, where these numbers come from, when. Um, so how would you trust this visualization? I could make it on my own with fake data. It would be exactly the same. Why would people believe this visualization when there is no way to trust it through some source, through some body of scientists producing that number? This is what we see every day, and this is a kind of uh, very appealing representation that, in my feeling, will not convince skepticals because there is no trust. They cannot put any trust in these visualizations. So what I want the designers working on this climate change visualization to do is to start with validated data and maybe validated visualization, and from then on work in order to improve that, keeping the link to the original data, original visualization, to keep the validation so that this representation can be faithful, trustworthy, and then improved. So how can we do that? Well, when I started this project, I thought, well, IPCC should have their data available. IPCC might have their figures available. Let's take them and let's improve them or redo them. So I searched, and searching a bit, scratching the surface, you end up finding out that IPCC actually, they distribute their visualization in a public repository, GitHub, and all of the figures are supposedly there. Great. So I went there and I tried to reuse them, because if I can do that, if I can take the data, take the visualization, improve them, give them to good designers, then they would really make a great work and help uh, convince many people. So I tried that, but it didn't really work. So why? Well, when you go there, the report and figure are there, except a few of the most important ones. So all of the figures for the main report are there, but the main report is designed to discuss, to explain to the scientific community, to climate scientists, to explain how all the calculations have been done. So they are extremely accurate, but totally impossible to understand. And all of the parts that are designed for the policymakers and the technical summary that are designed for more normal people, they are not part of this repository. Okay. But then, okay, let's start from the very technical one and try to simplify them. And then we try that and it's not working. So let me show you why it's not working and why we have been working in trying to make that possible. So if you go to the IPCC uh, GitHub repository, they have this nice table showing you where everything is and how everything works. So you're like, yeah, great. I have the data, I have the figure, I can start from there and improve that. But when you get the data and you get the figure, actually it doesn't work. And so what I did last year is I asked my students in my class, go fetch this data and improve them and show me some improvements that are interactive or better designed, etc. And they come back to me and they say, well, I'm sorry, but it doesn't work. I cannot make it work. I don't have the data. I don't have the figure. So I was like, but IPCC say it's there, so it should be there. So I went there and actually, no. Data is missing. Most of the data is missing. If you go there, the data is not there. Most of the figures are either missing or partial. And even if the data is supposedly there and the code for doing the visualization is there, when you try to run them, well, first you have to fight in order to understand how to run them. And then when you run them, it doesn't work. So it's very frustrating. And even if it works, even if you succeed in making it work, you get figures and they are not the ones that are on the report. So what's going on? So this is an example of a figure that actually is almost reproducible, but not quite. On the report, you have this nice figure where you have this map of the world in the middle. And for each part of the world, you have one sub-figure that explains the situation in the report. So it's split into multiple sub-continent figures. And when you run it on the repository, you have many small figures apart, but they are not connected together. And additionally, one is missing, the bottom right. And additionally, it's not quite the same as the final figure. So what we expected to be able to do, which is ask our students to take the figures, recreate them first, and then improve them, well, it turned out to not work at all. So what a pity. Even this seemingly simple process to have a start to improve the figures didn't work. So what we did is we decided to try to fix this problem. So with Lou, we created a shadow repository. You can access it. So this shadow repository is also on the same site, GitHub. If you are a web developer, if you're a developer, you know this site. It's a public site. It's owned by Microsoft now. And what we do is we have a project, and for every figure in the report, the figure has a directory in GitHub, but this directory, as I said, is not usable because it's not complete and sometimes very incomplete. What we do is we create one directory on our own, which actually points to this original directory as it's a mechanism called the Git submodule. And then around it, we wrap all the instructions to complete it and to make it work. So we have a few additional stuff so that now it becomes reproducible. So let me show you an example. So if we take the chapter 6, figure 8, the one that I was showing you before, if you go to the right repository, then you have a layout that is very simple. The layout is on the top right here. It mimics, it's always the same for all the repositories, and it allows you to reproduce the figure. So it has a script that allows you to install everything that you need to run the visualization. So it's the install.sh script. When you run that script locally, then you have an environment where you can recreate the visualization. It installs everything. And what does it mean concretely? It means that some climate scientists, they use Python, the language for doing their visualizations. Other climate scientists, they use R. Others use other systems. Well, most of them use R and Python. But of course, some use some version of Python, others use some version of R, and they use some libraries for Python or for R with some versions. And that's not part of the standard IPCC repository. So when you try to replicate this work, you have to dig and to find out what's the language, what's the version, what's the libraries. We collected all that, and we have this install thing that installs everything you need in order to run the visualization. So that makes your life much easier. Then the second part of it is you need to download the data in order to run the visualization. So of course, when you read the documentation from IPCC, they say everything is there. But when you try it, half of the data is actually where you expect it to be. And for the other half, we needed to send emails to the authors of the figure to say, hey, where is your data? And all of them replied, and they said, well, our data is here. Do you want it, etc. So we had it, but it was not at all in the right place and not in the right format. So now we have a way to collect the data in a standard way. And finally, we have a script, the final one, the run script, that when the data is downloaded and installed and the thing is installed, when you run the script, then it recreates the visualization or the figures uh, as best as we could. So what I mean by as best as we could is I'll show you a few examples. Is that what you have in the end is not what we expected. Ideally, we were expecting that when we run the script and we replicate everything, we'll have identically the same figure as the one that is on the report. Because if we have that, then we have a very clear reproducibility path, and we can say this figure has been created by IPCC and it's exactly what is in the report. Unfortunately, that's not the case. So in the case at hand, when I was showing to you let me get back to this example. In that example, in between the figure on the left that is on the report and the figure on the right, there's been a few steps. And the last one is that there's been some human editing. There was a graphic designer involved who took all of these images and put them all together with some lines to connect them in order to create the final figure. And this step is not automated, it's all manual. So what we did also for our project is that we are reporting if all of the input data, code, and library are all available, if the code is running, if the output is running, half running, or not running at all, if the quality is similar to what is in the report, and if there is a post-process that is automated, semi-automatic, or manual. So this is what you can get from the process. So we did that for all of the figures that are in the main project. And so things vary a lot from like this one is chapter 5, figure 4, which is complete. Everything is there and it's self-contained, to figure 3, which has some parts are there, some quality are there, but some are different. And the post-process is half automated, half manual. So in my mind, this process is absolutely necessary to make sure that when we start from visualization and data to improve it as a designer, as a professional, what we have has been validated and stamped by IPCC, for example. In that case, it's IPCC. Then on, nobody can come and say, I don't trust your data. Because if they say that, it means they don't trust UN, they don't trust IPCC, they don't trust climate scientists. That makes no sense. So if we follow this and we reuse that, we have the validation from all of these bodies. But then, in this current state, we still have a few issues because the final stages might need post-processing, and there might be some missing parts of some changes done after the repository, and so the final result is not the one you see on the report. So this is a problem still, but still it's better. So just to be clear, now we are discussing with IPCC because they are starting the new round. Current round is the report number 6, and they're working on the report number 7, which is supposed to come on 2027, 2028, and we are discussing in order to improve this situation. So just to show you. In some cases, the differences are not huge. So here you see the difference between the figure on the left and the figure on the right. So it's like kind of a game. If I'm asking you find the differences, you'll need to focus a lot, but you'll find them. So can I hear you? Can some of you tell me what they see in terms of differences between the figures?
Someone can try. I see the colors from the left to right.
Yes.
In the first ones, yellow is missing, orange is missing. Some other clues, other hints from the audience? I can repeat to Professor Jean. The right one has more continuous lines. The patterns are different. What more? Sorry, the margin is
Yeah, the
smaller in
margin
the
of
second one. Yeah.
yeah, exactly. That's true. So
Okay.
a few more. So yes, just you've seen that. So this is the exercise we've been playing with. We have reproduced the figure. We have the one that is printed. We compare them, and yeah, we see a lot of slight differences. And it's not fun to show those slight differences. So many of them has been probably done by the graphic designers who have done some changes, final changes to the figure. It's okay. I mean, changing the colors might be okay, whatever, but we don't have replicability, right? It's not identical, and we hope it would be identical. So yes, we are playing that game, like, well, find the differences. Same thing, you see those kind of differences with the figures. So the kind of funny thing is that those figures are horrible in terms of understanding. They all are very hard to understand. They use a lot of jargon or chemical compounds that we don't know about. But here you can clearly see on the left there is a nice frame around all of the colors of the figure. On the right, there is no frame. So you've seen these small differences. So it's almost reproducible, but not quite. So just to summarize, I can go over many examples. We have almost reproduced the figure, but not 100%. But it's a good start because at this stage, if you're like me, teaching visualization classes to different audiences, it's a very good exercise to tell them, okay, take them and improve them and tell me why they are improved. And they can do it. They can start from something. So yes, you can ask students to improve. You can yourself try to improve those visualization. Uh, and you do it from with IPCC data, starting from IPCC visualization. So you have the stamp of credibility. Uh, of course, you need to say it because in many cases, I was showing an example where the figure doesn't say it. So it's also a problem. I think it's part of what you need to do. So what others have done in the past in order to improve those figures. So let me give you a few examples that may inspire you if you are designer or if you are uh, teaching visualization or if you yourself try to make those figures more readable. So on the left, here you have the one figure from the IPCC report that shows the evolution before now, I mean 2015, and up to now, what are the possible scenarios. So that's the figure. So on the left, you see the figure. There are many things that are hard to pass. On the right, the BBC has made a great work to try to improve it. So what did they change and how could they improve it, but still keep the connection very clear and be able to say it's been validated. So don't mess with me. I know what I'm talking about. I have the data. I'm talking from the visualization created by IPCC. So first, what they did is they noted the source on the bottom. So if you create a visualization derived from IPCC data and visualization, you just state it. You can even be more precise. You can even say that it's the figure of SPM8 if people want to know. You have the traceability, so you benefit from the trust, and nobody can tell you what are you talking about because you have this stamp. So what they did is a very, I mean, obvious in a sense, but it's good to repeat it. They have simplified. They had they have explained a few things. They have added some annotation, and then they have maintained this chain of trust. I think that's really the main message. So the explanation is instead of showing the figure with the text around, but nothing. They have added more text. How much hotter could it get? That's the question. And so there are five possible scenarios, sorry. So on the left, they use the jargon of IPCC. And the jargon of IPCC calls them SSP5, SSP3, SSP2. So of course, if you're talking to your grandmother or your son, they will have no clue what SSP5 means, and they don't even know it's a scenario. So on the right, they removed all that jargon and they say different possible scenarios. There are 5 scenarios. We present you the 5 scenarios. So get rid of the jargon. Second thing is they have added annotations. So on the right, they say that this is observed temperature. So this has been observed in the past. And then the other ones are, of course, made from models. So it's predictions. So it's not observed. And so this is a future. And they explain that this is a future when you use a lot of fossil fuels, the temperature will raise of up to 5 degrees in this scenario. And this is if you are more towards sustainability, where you can maintain the temperature maybe below 2 degrees, maybe not. So there are those annotations that are very important. So explain, simplify. So in that case, the simplification from the removal of the jargon, but also on the left, you can see those bands, and those are uncertainty bands. So it's very clear that the general public doesn't understand uncertainty. It's very complicated. Even us as professionals, we have a super hard time making sense of this uncertainty. So if you want to communicate to a lay audience, just remove the uncertainty. You can mention that later, but since you don't have very clear numbers anyway, the uncertainty is not really essential for the communication. So this is one example of how to simplify a figure, to make it understandable, and to keep it trustworthy, but really to redesign it in order for other people, many more people, to understand it. So just a small comment. If you show that to a IPCC climate researcher, they will faint. They will collapse, because IPCC climate scientists, they are extremely nervous about this idea that somebody could lie or could make mistakes. So when they create figures, they want all of the detail in the figure. You cannot explain to them that you need to make it simpler, because they cannot stand it. So it's okay. There are scientists, they want all the details, fine. As designers, you can do it, and it's your responsibility. You can sign. So here, BBC has signed. So it's a version from the BBC, which is a simplification. So BBC takes it on itself to simplify this figure, and it's okay. But don't expect climate scientists to make this simplification. They won't be able to. And we discussed with the people in charge of creating this chart, and they say they were not able to convince the scientists to simplify the charts themselves. They don't do that. So some other examples of changes in the communication based on IPCC data. So this is another example. This has been published by The Guardian. And you see that in that particular case, the graphic was okay. It has some annotation already, but still it's kind of tough. If the message is that the observed temperature are rising super fast, just make it super obvious. So here it's underlined in red, it's an annotation, and there is a text that says that human influence has warned the Earth at an unprecedented rate over the past 2,000 years. So I think this is an example where, again, you have this trust. You cannot dismiss this chart saying the data is not right, the visualization is not right. But On top of that, you have a message, and the message is highlighted. And other things are basically low lighted, so it's basically grayed out, so it doesn't take too much focus. And there are some annotations on top of it, which are not obvious. For example, this is a reconstructed multimodal average. Maybe it's a bit too complicated, but this is not; those are not the real temperature recorded. Those has been reconstructed. So it's good to be trustworthy and to explain that. It's also on the left, but reconstructed is a bit short. So last week at the VIS conference, there was a nice workshop on visualization for climate exchange. I advise you to take a look at all the articles that have been presented there. They're all available online. And same thing, there was some very interesting papers explaining that you can use cartoon style in order to present IPCC data and to add explanations and to add annotations, and still you maintain the chain of trust. So they were showing many examples. This is one where they were annotating IPCC data. So they didn't change it. They could, but as I said, this is not IPCC data. This is other data actually. And accessing the source of this data is super painful, and this is probably why they haven't done that. So now for IPCC you can do it, but in that case they couldn't do it for the data. But at least on top of it, they have added annotation, explanations, and then and also they maintain the chain of trust. In all of the figures they put the reference to their source. And so this is something that I really want to highlight, that in order to be able to convince people, you need all of these ingredients: explaining, simplifying, annotating, and maintaining the chain of trust. So we are working on trying to improve this process and formalize it. We're working on creating also learning objectives to be able to test with experiments that our simplifications are actually improving. We are asking questions to people and hope they will answer those questions better with our simplification than without. So we are making some more validation steps and collaborating with IPCC to also integrate some of our methods in order to simplify the reproducibility. So this is really important, and really our goal is to keep this chain of trust and allow a much wider variety of people to be able to understand this visualization, despite all the deniers who are trying to interfere in this communication. So just to conclude, so how do you create good visualization that are still trustworthy? So first, we've made this IPCC repository where you can reproduce most of the IPCC figures, not all of them, unfortunately, but most of them. So you can start from there and you have the trust. Still, there are a few things missing, but it's not bad. We need to improve that. We need to have some more tests in order to make sure that the simplifications are really improvements. So to ask people and to make sure that they better answer questions, but at least they can understand. And one warning is that this is not the end, because doing that is the first step towards trying to reconcile better design with trustworthiness. But remember that there is a fight between people who are adversaries. They don't want people to make any actions against climate change because they are selling oil, or they are selling things that are actually against. I mean, they are not against climate change. They don't care actually. So there will be a fight. So even if we do that correctly, there will be countermeasures. But at least we need to start with these improvements. And I think with this way of working, keeping the trustworthiness, but allowing designers to create much better design, I think we can go a long way and convince much more people who are skeptical. And I think it's important to be skeptical, but could be convinced with good designs. And right now, these good designs are not easy to find due to the difficulty of the problem. So thank you for your attention. And if you have questions, I'm ready to take those questions. Thanks a lot.
Thanks, Professor. Really inspiring talk. It's really important to think about these things out of the box. So it's really cool. I believe you cannot see the people here, but I can make the questions, or if someone wants to come here and to ask directly to Professor, so he can see you. No worries, you decide. So, do you have questions? Is it possible to change the camera to the audience? I don't know. If yes, okay, I can change that. This
Good.
one.
Great. I'll be able to see the audience
Yeah,
much
that's
better.
quite important. Let me
Yes, it
see
is.
here.
Hi, guys.
Okay,
Nice
that's
to see
good.
you.
Far better now. So, anyone wants to be the first? We have some a first question online, but we can start here. I don't know. What do you prefer? I will break the ice. There's one.
I'll try if my voice allows. My question is, how can you make this process scale? Because you have, many people producing data, many people producing visualizations, and this is a very nice effort. But have you thought about or have ideas on how to make it scale to cover more of what's being produced?
Yes. So the truth is that there isn't so many institutions creating the data with the quality of IPCC or NASA. So the process of IPCC is really very complex, and before any figure goes out to the public, it's discussed in a plenary session with maybe 150 or 100 climate scientists and from all of the countries and some representative, and they have to agree so that they have a stamp. So I think scalability in terms of the work of IPCC, I cannot imagine so many institutions creating so good and consensual data and figures. So this is an initial step, and I think this is very important. So I don't see a point in terms of scalability for the creation of the data and the figure. The data and the figures are already there, much more than the general public sees, because it's too complex most of the time. So my take is that we have all the data, we have initial figures, and most of them hard to understand to explain the phenomena. So there is no scalability problem, I think, on that side. On the other side, we have tons of designers. We have millions of people who would be willing to improve the designs to help communicate. And what I mean by that is you may want to explain to high school students why there is climate change. You may want to explain to even kindergarten students what's going to happen in the near future about where you cannot build houses next to rivers because the river may overflow and flood. So you may want to have designer work for different segments of the population to explain this problem and reuse the data. And yes, there is a scale in terms of designers trying to create good representation to explain to the population. And for that, I think if they start from existing data and existing figure, they are halfway to what I was talking about. They can create the figure. What I want to is the other halfway. So my vision or my view is to establish some kind of peer reviewing or reviewing process where you could, as a designer, create new designs and submit it to a reviewing process where climate scientist and visualization practitioner would see your design and would check first, is it really following the data accurately and get inspired by the visualization accurately, not changing the message. Hopefully if you tested it on the population, they can check that the tests are pretty good and put some stamp. So I know you're familiar with that, Nivan, but in the computer science community, when we publish articles, we of course have a reviewing process, and the reviewing process allows the papers to be published. So it's a first level of stamping to say that this work is valid to some extent to the reviewers. But now uh, conferences and journals also have a stamp for replicability. Many conferences do that. So if you have a figure in your article, you can submit to another body, and this other body will take your article, will take your code and your data, redo all your analysis or rerun your program, and verify that what you have in the end of the program is exactly what you've published in the article, and put a stamp on it to say, okay, this is replicated. So what this author has published in the article is actually valid. It's really what they have done, and it has been replicated. So it's a stamp of replication. This gives a huge validity improvement to the paper, because in the past, it's been really a drag to replicate the work of others, and sometimes it didn't work. And you hear a lot of stories about the crisis of replication, where many articles in the past have not been replicated because they've been forged, actually. So my view on that is, if we create a process like that, where there is a reviewing process, possible reviewing process, we could scale, and we could also keep this stamp of trust from the data to the final visualization and validating the quality, in order to avoid, having people doing bad visualization, not using the right data, not using it properly, and so hurting the cause in a sense, or obfuscating the cause, because there will be attacks trying to obfuscate the code. So this is my view, but of course this is not done, and we will be working on that.
Great,
Sorry,
Professor. Thanks. We
sorry
also
for the
have
long
more.
answer.
No worries. We have more questions here online. I'm going to condensate two questions in one, because it's related to the IPCC relationship that you have. So the first one from Igor is, if you try to contact IPCC directly to discuss this lack of availability of their data, not just the scientists, but the community. And the second one from Pierre Dravjivsevich.
Ceviche, yeah.
Ceviche, I'm
Yeah.
sorry. I'm sorry, Pierre. If IPCC people don't like simplified versions of their charts, can we really say that those charts are endorsed by IPCC? Doesn't that break the chain of trust to some extent?
It's a good question. So, okay, so first, IPCC, I think many people are trying to contact IPCC. We've been very fortunate to be able to connect to them. But IPCC is an emanation, is a creation of the United Nations, and is run as a UN organization. And so probably most of you are not familiar with those United Nations organization, but they are extremely heavy. There are 180 countries part of it, and they need to uh, agree on most everything. So this is a very heavy organization. All the decisions have to be made by committees and take a long time. So I think that, I mean, my feedback is they are doing their best, but it's extremely heavy, and I think they have been working so far to do the most important part, which is to have this report out, to have the good models, the good information, and to do the modeling of the future, and to model first, then see the outcome, and then give advice on what to do next. So they've been trying to do that. And the communication for the lay people was not their priority, because that was not in their charter. So communication to the lay people is not in their charter. They will not do it if it's not on their charter. So we can try to convince the United Nations or IPCC to do it and to add it in their charter, but it's not there. So, but besides, they agree that it would be great, and they collaborate with many people with a limited resource. So it's great. And now that in the science, and especially in the climate science, people want more reproducibility. They are aware that they need to improve the reproducibility, but they explained to us their process, and it was extremely complicated. And so this is the reason why for the AR6, the report 6 2021, they were not able to make it perfect, but they are ready to help. And as I said, when we contacted directly the scientists who created the figures and collected the data, they answered to us after usually quite fast, and they give us the information. So they are really willing to do it, and they will certainly improve it for the next iteration. So now for the chain of trust, I think this is an interesting question. I guess my answer is that only the IPCC report is stamped by IPCC itself. So I'm not expecting you as a designer, if you create a nice design, to have a stamp from IPCC. That's not the case. But what I'm expecting is that like a reviewing, the reviewing is not something that tells you that you are right. The reviewing says that what you've been doing has been done according to the rules. And so if reviewers who can be computer scientists, designers, and climate scientists say that your version of the design is using the right data, is not creating anything visualization that are wrong in any way, that you've tested it somehow, and that it looks like the original one with improvement as discussed by the designer, it can be validated, but it's not validated by IPCC. So I think this reviewing process means that there needs to be some human in the loop to double check, to make sure that you're not making any mistakes, because even you as designers, if you're not familiar with climate science, you can overlook some details, remove it because you think it's a detail, but it's not a detail. So then you can be warned. And so my feeling is that this human reviewing process will give more trust, but it's not the level of trust that you have with IPCC data for sure. But if you don't do it, again, the problem is that people who are skeptical, and again, they can be skeptical, will say, I don't have any reason to believe that what you as designer are presenting to me has any validity. Why? Where does the validity comes from? And this is, I think, in my opinion, this is one of the reasons why there is this split. So I think this chain of trust is better than none, better than just somebody saying, I did it and look, it's great, because we don't have any proof that everything has been done properly in the process. So I agree that there are some different levels of trustworthiness, but having that level would at least improve quite a lot the chain of trust.
Great. We also have some questions, Professor, but we are reaching out of time. I don't know if you can stay for more 10 minutes. I don't know. It's
sure.
An invitation. If you cannot, there's no problem with that.
No, okay, I can stay for 10 minutes. That's fine.
Okay, that's amazing. Georgia, the next one is from you. You can make the question.
Hi, thank you for the very interesting talk. I think my point comes to some recent research that has come up in terms of COVID visualizations, because we had the same kind of discussion there about trustworthiness and everything. And that research, I guess, has showed that even people that are skeptic and have adversary role, like they're contradicting the main narrative, let's say, of the scientists, still use proper design practices to communicate that insight. So I guess my question comes down to, are we paying too much attention to, not too much, maybe it's the wrong word, it's too extravagant, but maybe are we spending too much thinking about how we're designing visualizations, rather than other kind of topics that maybe like where are they placed, or where are they context, or other dimensions that seem to influence as much how much people trust this? Does that make sense as a question?
It does. So, okay, but I didn't want it by any means to say that it's the only way and it's the most effective way. I don't think it's the most effective way to convince people anyway. But my position is to say that if we do not do that as scientists, we are not doing our work correctly. So as scientists, we need to make sure that our communication toward the public is as clear and reliable as it can be. And I'm okay with people who are skeptical or who have another interpretation of the data. I just want them to present their facts in a way that can be traced and can be verified and can be discussed, and then we can discuss. So if these people are ready to follow the same process and to submit it to the same review process and to have it stamped as it's using the right data, it's using the right visualization from IPCC. But my conclusion is that there will be no global warming, because at some point, 10 years from now, everything will get colder. They can do it, and they may even be right. I mean, it's very possible that there will be some huge comet coming from outer space that will blow up on Earth and just cool down the planet for 20 or 200 years. That's very possible, and that's a hypothesis. I wouldn't bet the life of the planet Earth on this event to happen, but if they want to explain that, it's fine, it's fair, it's true. The probability is very low. If they have an alternative interpretation, they could do it. So it's true that many of the deniers are trying to use these things. I think what they will do instead is they will create another reviewing process, just like we see in the predatory journals, to try to say, yes, this has been validated by all my friends in the oil industry, and this is as valid as the others. But this, we know about it, so we can at least try to avoid it. But my point is to say that if they are ready to play that game, let them play that game. But I don't want to give up on trying to have a fair and clear communication on those facts, because I think that's the first level of communication we owe to the public. And as scientists, we need to do it. Then whether it's the most effective way of convincing people is another question, and I think you're right. My personal belief is that the best way to convince people is to convince the kids, because the kids don't have a dream to have a big house next to the sea that they had since they are younger. The kids, they see the world falling apart, and they will be very sensitive, and they will say, okay, stop trashing the earth. But this has nothing to do with my function or my role as a scientist. As a scientist, I need to provide clear and convincing and understandable information about the situation for people to make up their mind and eventually be convinced. And if they're not convinced, then somebody else can try again. But I think we have not been going in the right direction, or I mean, not enough to try to improve the designs so that more people can understand. That's my point. But I agree with you that there are a lot of ways to try to solve or address the problem, and the visualization is a very small one. But if we don't do it, then we are not playing our role.
Thank you.
Professor, one final question here from the online audience. Aymeric Ferron. He says, it seems that adding uncertainty into graphs makes people doubt about the data, or makes the graph less understandable, like your slide 25. However, it's an important part of science transparency. What kind of trade-off we create between having complex uncertainty representation and simply removing it? Could we educate people about this important concept? How can we do that?
Excellent question. If you answer that question, you have a PhD. Okay, uncertainty is a hot topic in visualization, and it's very hard. So the situation, just to summarize it, is the following. If you have a visualization that is already quite complex and you want to add information about the uncertainty, then the visualization becomes even more complex. And besides, um, it's very hard for the human brain to grasp what uncertainty means. So there's been a lot of experiment on that, and there are a lot of misunderstanding about uncertainty. And if you ask question, people make bad answers or make bad decisions when you show them something that is supposedly uncertainty. So uncertainty is very hard. My position is I have my position is that if people don't understanding, I don't see the point of showing it, but I agree that it's very important. So if you know how to show it in a way that is understandable and convincing, you have to do it for sure. I I am not sure I know how to do it, and it depends on the public also. If I'm talking to high school students, maybe I can, depending if they're on STEM or not on STEM, but maybe I can explain something and I can help them. But if I'm talking to younger people, they won't be able to understand. If you talk about your grandmother, try to explain to her how uncertainty works. I'm sure it doesn't. I'm not sure it works. So my feeling is that yes, in important, we need to work more on trying to find ways to convey uncertainty. For now, my best answer is to create interactive graphics. You show by default something that is simpler, and you allow people to raise the complexity interactively step by step. So you don't hide the complexity, but you don't show it in the first place so people can make sense of the visual. Of course, if you add interactivity, you can do it if you show an online version of the graphics, but if it's printed in a newspaper, then it's much harder to show something interactive. But there might be some ways, but there is a huge tension between showing the uncertainty and not obfuscating the visualization. And right now, I haven't seen a lot of convincing work to show for lay audience the uncertainty in an understandable way. So I think this is a very important problem. And before we solve that problem, I think if we want to explain the situation, we can certainly remove the uncertainty, because if we add it, then it makes the figure impossible to understand and nobody can make sense of this uncertainty in the end. So I'm super sorry about it, but I don't know what to do except maybe showing it layer by layer. But showing it all the time is not working and is making it impossible for the lay audience to understand the figure, I think.
That's great, Professor. Let's thanks again, Professor Jean-Daniel Facchetti.
Thanks.
It was a great pleasure, Professor, to have you here. If you have any more questions, send to Discord or send directly to Professor Jean-Daniel also.
Yeah, don't hesitate.
Yeah, exactly. Thanks a lot. So we close this section, and now we are going to open the final section, small closing for our event, or the first part of the event. So I'm going to pass the word to Professor Luis. Gusto.
Thanks, Chico. So we had like amazing presentations. I know that you enjoyed it a lot. I hope that you learned a lot from those diverse persons. I did. So now we're closing this public part of the event. I hope the general public participants enjoyed it. And that's it for the PSVS 2024 for the general public participation. And now we're going to have an amazing workshop led by Sarah Hayes this afternoon for the expert participants. And that's it. Thank you very much. Thank you, Jean-Daniel, and all the other presenters. So let's have lunch now and let's enjoy this break and let's chat.